Hey, welcome back to the series. We did not configure our database yet. It is time for us to configure database and use the data from the database. So we have used test data, which is a sample JSON file in the previous episode to test our endpoints. In this episode, we are going to see how to set up PostgreSQL and also how to use Sequelize ORM framework package in Node.js. And also we will handle all the queries and we write all the code in repository classes which actually talks to the database and send the data from the database to service layer, which eventually serve those endpoints. Let's get started. Before getting into the code, we have to do two things. First, we need to run this Postgres app, which actually runs Postgres database on our local machine. And we have to initialize it so that the database is running. And the next tool is pgAdmin 4, which is the graphical user interface, which connects to this database, and you can create servers and you can create databases. You can run a lot of queries against the database, which is actually running on our local host. So you can do a lot of other stuff with this pgAdmin 4. So make sure you install these two things on your local machine. And here is a Sequelize, which is a ORM framework for a lot of databases. It supports Oracle, PostgreSQL, MySQL, and other stuff. And let's take that install command and run it on our app. So we have to install two packages here. One is Sequelize package and another is PG package. Since we are connecting to the PostgreSQL, so we have to install that package as well. And we need to create a configuration file where we need to put all the configuration related stuff. So I named it as dbconfig.js. You can name whatever you want. So as a first step, we have to import that Sequelize package. Since we have installed that Sequelize package, you can import with require command. So let's do that. So it's always good to maintain separate configuration file. You can put all this code in the index.js, but it's always better to maintain a separate file. So after that, let's create a connect method where we write code to connect to the Postgres database and export this object. And you need to export this object so that you can import this object in another files and you can connect to the Postgres database. Now let's define some parameters, like some variables called host name and username, password, database. So since you are running Postgres app, you can actually see all the databases, all the database that you created on your local machine. You can see on the Postgres app. So let's not worry about the variables right now. We can actually let's not worry about the values. So we'll add those values later. First, let's write a code where it connects to the Postgres database. So we have to pass all these variables to the Sequelize constructor, which actually takes database, username, password, and options. So in that options object, you can put a lot of configuration details. So like host and also pool object, and there are so many other options you can put here. And there is a documentation for all these parameters, why we are using these and why we need to pass dialect and why we need to pass operator aliases. So all these things there is a good documentation on Sequelize site. So let's not waste time talking about those, but but these are very self-explanatory. For example, dialect is since Sequelize is the ORM framework which talks to different databases, so dialect is the one which you need to pass. For example, we are connecting to PostgreSQL here, so we need to pass dialect as Postgres or PG. So here we are defining pool object where you can define maximum number of connections and minimum number of connections, and also how long you have to wait to before you acquire a connection, and also how long you should wait before you release a connection. For example, if the app is idle or not talking to the database for 5 seconds, the connection will be released. So all these options you can configure, and there are a lot of other configuration options as well. You can check the Sequelize site, and we have to define an object, and you need to assign the Sequelize variable to the object, and you need to return this object. So all we are doing is we are creating a connection, and you are assigning that connection to the DB object, and you are returning the DB object. So this is just a connection. So what about the models? So the models, you can register the models in the same way you register the Sequelize. The same way we assign the Sequelize connection to the DB object, we can register the models here. So for that, first we need to define a model. So let's put a comment. We'll come back to this later. But for now, this is a configuration file where we can connect to Postgres database. And let's go to other window where we can actually see the database. Here the Bachina, Postgres, all these database names. So let's try to connect to the database through pgAdmin 4. The name, we can give any name here. It doesn't matter. So I'm just going to name it as a same as database, and then host name is localhost. Since our Postgres server is running on our local machine, you can just put localhost as a host name, and port 5432, which is default, and the username Bachina, and the password, there is no password. When you are running Postgres app on our local machine, there is no password. And yep, it's connected. Now you can actually see the database Bachina, and also you can see schemas, tables, a lot of other stuff. So we have to give the same names here. So host name localhost, username Bachina, password, we don't have any password, and database is Bachina again. So make sure the database name and the host name, everything is correct, make sure. And also dialect, it's a PG. Now let's create a table. Since we do not have any tables, so let's create a table first, so that we can write a model and you can register the model in the DB object. So let's create a script. Let's click on the create script, and you can remove all this auto-generated code. And here you can put a create table script where we are creating tasks table. So when you run it, the table is already created. You can open and see the table, whether the table is created or not. Yes, it's created, and all the columns are already there. When you right click it, there are so many options where you can see the properties, in the properties you can see all the columns. Even you can actually change the column here, or you can change the length of the column and other stuff. So these are the general settings for that particular table. You can define constraints, and you can put roles, or you can write queries. It's very handy to do some stuff immediately. So let's go back to our code, and here we are creating a model, task model.js, in which we are actually defining a model, which is the database. So basically we are mapping. So ORM framework is nothing but object relational mapping, where we are actually creating a object, and the variables or fields are mapped to the table columns. So let's take these Sequelize data types and model, and data types and model are coming from Sequelize library or package. So for that, first we just need to define a model. Let's create a model. Since our table name is tasks, so I'm going to name the class as tasks here, and it extends model. So the model is coming from Sequelize package, so you need to extend that model. Once that is completed, tasks.init. So the initialize method takes two parameters. One is the object, which is the exact mapping to the table. So let's copy all the column names here so that we don't have to go back. So since ID is a serial or a sequence, we don't have to define that ID. Let's remove the ID. So let's define the columns from task. So task, and you can define type. It's a task is a string, and the varchar. So varchar is mapped to string here, and you can put whether it is required or not. So allow null is nothing but it's required. Allow null false is nothing but it is required, because it is not allowing null values to that particular column. So let's copy that multiple times so that you can just copy the name of the column here instead of writing the whole thing. So let's copy column names. So since created date is a timestamp, you have to change that string to date, and updated date also is a timestamp. And the last one, created by and updated by. So let's create another field called updated by. So this is a first parameter which you need to pass to the init object, or sorry, init method. And another one is you need to pass Sequelize, and also let's see what you need to pass. So the another object is yeah, some of them are not required. I mean, so updated by, updated yet, those are not, those can be null. So let's remove those. Sorry, I was talking about the second parameter or second parameter that init method takes. So you have to pass Sequelize object, connection object in the second parameter. Let's pass that. And also the model name. Since the model name is tasks, you have to name that as tasks. And let's return this tasks model or class. So this is how you define you define model, object model, or relational mapping to your columns or to your table in PostgreSQL. But this is way we write in Sequelize. So now we have a model object or model. So it's time to register those. Let's register with the db tasks equal to, and you just need to assign to the field called tasks on the db object. Since that model takes 3 parameters, Sequelize, data types, and the model from Sequelize package. Now we have completed the configuration and configuration details and also model, and let's import that in the repository class. So once imported, we can connect, we can initialize the connection in the constructor object. We can define this in the index.js, or you can define this constructor in the constructor of tasks repository. Since we have only one tasks repository class here, you can initialize the connection in the constructor and assign that connection to the db object. So for the development, we can always resync whenever your server restarts. It actually deleted all the data and reinitializes. So you can only use this for development. For production, you should not use it. Yep. Now we have started the application, and there is no data in the table. So that's why we got the empty array. And let's insert some code here. Let's run this, and we have inserted, there is a error. So let's insert. Now query inserted successfully, and let insert one more time, change some values and insert one more time. So we have 2 rows total finally, and when you hit this, you actually get the data from the database. So that is how you connect to the Postgres database, and that is how you query through endpoints in NodeJS. So we have to define the connection object, and also we have to define the model object, and through model and connection using Sequelize, you can serve those data through endpoints in NodeJS. Until now we have tested only one endpoint. Let's go ahead and update all the methods in the repository class so that we can test all the endpoints, all the CRUD operations as well. So let's update this with the create. So the create task is the post method where it takes task as a body and pass that body to this particular create task method in the repository class. All we need to do is we just need to call create method on the tasks model. So before that, we just need to update certain fields. There are columns called created date, updated date, or updated at. So we just need to update with the new timestamp. We can always pass these in the post body as well, but it's better to actually assign those values here before we insert those into database. And the create method will only take body as a parameter. So the create task is completed. Let's go ahead and add the body for update task. So basically we have for update task method is used to update the record in the database. So that means you need to know what is the ID for that particular record to update. So that's why we are taking two parameters. One is task, the entire body, what to update, and another is ID. So with ID you will find the record and update the body. So for that, the Postgres model Sequelize will take the update method will take two parameters. One is body and another is options with where clause. So with where clause you have to make sure you need to pass the ID so that the model will find the particular record by ID and update whatever you pass as a body. Since we are updating the record, we can just update, we can just assign update yet with a new timestamp. So finally one more method is remaining, which is delete task. So this is used to delete the record from the database, from the table. So in Sequelize, to delete the record, we have to use destroy method. So the destroy method will only take one object with where clause, where you need to pass ID of the record. So it will look for the ID and it will just remove the record by particular ID. Now all the operations, all the methods in the repository class are updated, and let's go ahead and retest the application. So we have completed one repository class and we have two more. So one is detail repository and another is history repository. So first of all, we need to move all the methods to one repository class because we have only one model. So since we have only one model, we need to move all the methods to one repository class and use that repository class in all the services. So that is what we are doing here. We are importing task repository instead of task history repository in the task history service. So that means all we need to do is create two more methods for list tasks by username and archive task to delete the record from history. And we need to create these two methods in the task repository and use those. So before testing the history routes, let's create some records. And we are creating the records here, and we are seeing those records are created by get method. And let's go ahead and test that history URL. So basically the first URL of the history route is we need to retrieve all the tasks that is created by username. So that means you have to pass username as a parameter. Let's test it out. So to-do/history is the path. So you just need to give that we just need to give correct path. So to-do/history/ that username, whatever the username it is. So now I think there is an error. Let's see what is the error. Let's find out what is the error here. It seems it is not able to find a find method on tasks model. So that means there is no find method, I believe. So let's see what is going on here. So if you go to the list task in the repository, we are using the find method to find all the tasks by username. So we have tested find all, that is working fine. I think the find, there is something wrong with this find. I think we need to go to the Sequelize. Let's see what is there any find method in the Sequelize model object. So we have find all, find by pk, and find one, and find or create. There is no find method basically. So let's go ahead and update that. Yep, now it's working fine. So before testing this, we need to insert the records again, because as we are using resync DB for the development. Yeah, let's create some records. And the username is created by user1. So let's create some records and retrieve these records by that particular username using history service. Yep, now the call is working. So one thing I wanted to see here, there is a find one. So that's why we are actually getting only one record. So instead of find one, we can just use find all. Again, we have to insert the records, because sometimes it is frustrating to resync the database. Every time you make any changes in the DB, you can comment it out, that particular line, so that all the data that you created before will be persisted between restarts. Yep, now we have created multiple records, and we are actually retrieving all those records by username. Now the archive task. So all archive task is nothing but, so basically we need to move from sum table to archive table. But for the testing purpose, what we are doing is we are just using destroy method, where it actually deletes that particular record. Let's use a write path. So we are just deleting one particular record. So with the delete method, so yes. Now you can you can see the get URL will give you only few records. So that's about the history service, and let's go ahead and test the detail service as well. So this detail repository has three methods. One is get detail and edit and the destroy. So you have to copy those methods from that repository to task repository, and also since these operations are very similar, we can just use the same methods. So get detail will, so since we are actually getting the detail information of one particular task, we can just use find one for the get detail, and we can retrieve that by ID. We just need to copy that task repository and import that in the detail service. So let's import that repository, task repository, in detail service. So once imported, we can just use it instead of task detail repository, which is already deleted. Since remember, since we have only one model, we are just using one repository. So the get detail method is completed, and now we need to update. So the update is very similar to the update task in the task service. So we can just use the same. And the archive task is also very similar to remove task. So we can just use the same thing as well here. So remember, in a production environment, when you are archiving some stuff, you have to move frequently accessed database to infrequent accessed database. So we have to move items from that database to some other database which is infrequently accessed. But now here we are just testing it out, so we don't have to do all that complicated stuff yet. But always remember, removing task is different from archiving task. So that is how all the services are done, all the repositories are completed, and we have tested all those as well. And here we are going to test one more. So this is how we get all the details of particular ID, and here is the. So as we change the ID, you get the details of that particular ID. And then let's test the delete. Yep, delete is also working fine. Okay, that is how we set up PostgreSQL in NodeJS application REST API with Sequelize ORM NodeJS package. So I hope you find this very useful, and if you have any questions, put those in the comments. And thank you for watching. Don't forget to subscribe.